In this video, we will be solving 8 practice questions about logarithmic functions. Let's start. If you haven't, just if you want to know more about logarithmic functions, you may skip this video and open the previous one before this. That way you may be able to understand more before you start answering. After learning, it's always vital to practice what you learned with practice questions. And that's exactly what we're going to do today. So instructions state that we have to solve the following equations. Again, just to recall from what we've learned in the previous video, to solve logarithmic equations, we have to convert logarithmic equations to exponential, find the common base, and solve for x. That's it. So let's solve for number 1. Logs of 3 times x is equal to 5. We switch the values. Left will be at the right values will be at the left. So we have this, and convert this logarithmic equation into exponential. Okay. The sub-value of the logarithm will be the base at the left side. The exponent will be the 5 at the left side. And our x will be the number at the right side. So x is equivalent to 3 raised to 5. 3 raised to 5, I suppose you can calculate this mentally or solve it by hand or by calculator. The answer is 243. So in this problem, we didn't really need to find the common base, because after converting the logarithmic equation into exponential, there is no need to find the common base, because they are already the common base, these values. For number 2, logs of 4 times x is equivalent to 3. We swap the values. What's on the right will be on the left. What's on the left will be on the right. So our result will be this. The sub-value of log, the base, will be at the left side, the base of the left side, and the 3 will be the exponent, and we have x. 4 raised to 3 is equivalent to 64. For number 3, we swap the values again, write it in this fashion, and 3 will be at the left side, 3 raised to 2, then eliminate the log. We copy what's inside the parentheses. So yeah, 2x is equivalent to 9. Transpose 1 to the other side, we get minus 1. 9 minus 1 is 8. So x is equivalent to 4, because 8 divided by 2 is 4. Okay, for number 4, again, sort the values, right to left, left to right. 5 raised to 3, then copy what's in the parentheses, x minus 10. X is equivalent to 125 plus 10. Transpose 10 to the other side, it will become positive 10. And we get 135. Let's move to number 5. So this time, we can see that we both have ln on both sides of the equation. In order to solve this, it's quite simple actually. I mentioned in the earlier video that Euler's number is equivalent to ln. If you see logarithmic equations with e, you counterpart them with ln so that they can cancel with each other. If you see equations with ln, probably on both sides, place e on both sides, they cancel each other. So that's it. In this situation, in number 5, we multiply both sides with e, then ln x plus 4 is equivalent to Euler's number, then ln 7. Therefore, we can cancel both sides with e and ln respectively, and we get x plus 4 is equivalent to 7. x is equivalent to 3, and that is our final answer. Right, let's move to number 6. Now, we can see in this situation that there's only ln on one side. It's quite okay. We still have to multiply both sides with e this way, and place e at the other side. So this will be e raised to 6. Cancel e and ln at the left side of the equation, so we get this. Now we place a plus minus sign. What we're having right now is a quadratic equation involving Euler's number. So we place both sides, one with the positive and one with the negative. So x plus 2 is equivalent to e raised to 3, and x plus 2 is equivalent to negative e raised to 3. Now, don't forget the objective. Upon simplifying or solving the following equations, what we have to do is to solve for x. So x is equivalent to e raised to 3 minus 2. Basic literal equations. When we have two variables at play within an equation, there is an instruction that we should solve a specific variable, solve for a specific variable, and we don't know the value of two or more variables. Therefore, we focus on one, and we just leave the other value that's not being found as is. So we write it like this. What we're trying to find is x. We're not really trying to find Euler's number right now, or maybe whatever that variable is, maybe y or z or g or f. Yeah, that's it. That's all I have to say. On the other side, we have negative e raised to 3 minus 2. That's it. Finished. I'm not exactly sure if only one of these answers are correct, but as far as my answers are concerned, they're already checked by an official teacher. They're correct. They are correct. Maybe there's a specific rule where when solving quadratic equations, the value with the negative value is eliminated. It's considered an extemporaneous solution. Maybe that kind of law doesn't apply to this right now. Maybe in the future. For number 7, all we have to do right now is to transpose all the constants to the right side. So negative 14 will become positive 14, then you add it with 11, 24, 25. Divide both sides with 3 by 3. We get e raised to x is equivalent to 25 over 3. This time, we have Euler's number. Multiply both sides with ln. Ln raised to e raised to x, ln raised to 25 over 3. Cancel. To eliminate Euler's number, we have x is equivalent to ln raised to 25 over 3. That is our final answer. I suppose that you can still find the exact value of this expression in your scientific calculator in decimal form. I won't be doing that right now, but you can feel free to do so. For number 8, you have to take note of one integral technique. 2 log sub 4 times x, you can rewrite that as log sub 4 times x raised to 2. Basically, the number 2 before writing log can be transferred as an exponent of x. That is to avoid the confusion, because sooner you'll be compiling logs of 4, logs of 4. Since, similar to fractions, when, for example, you have 1 over 2 plus 3 over 2. They have the same denominator, you can add them. So 4 over 2 is equivalent to 2. That kind of situation is similar to this. This time, these expressions have the same logs of 4. Therefore, you can combine these according to the sign that is being represented. This time, it's subtraction sign. Therefore, subtraction represents division, while addition represents multiplication. Please take note of that. So, alright, let's remove this. Okay, log sub 4. Because we have a subtraction sign, of course, we divide. So, numerator will be the first expression. Then, the denominator will be the second expression. So, x raised to 2 over x minus 1 is equivalent to 1. After that, we multiply both sides with 4 because the base of the log is 4, I suppose. That's my hypothesis. It's not exactly proven, but I suppose it makes some sense at some point. So eliminate these two, and this will become 1 times x raised to 2 over x minus 1 is equivalent to 4. Multiply both sides with the denominator at the left side, this part. So x minus 1 cancel the denominator and the external expression. We get x raised to 2. X raised to 2 times 1 is still x raised to 2, so we don't have to write this anymore. For distributive property, 4x minus 4. Then, x raised to 2 minus 4x plus 4 is equivalent to 0. Place all the values at the left side and leave alone 0 at the right side. At this point, you can see obviously that we're solving quadratic equations. So, negative 2, negative 2. We have two choices. We can either still solve two ways, but because they're the same, these two are the same, it will just yield the same answer. X is equivalent to 2. So that is our final answer. So yeah, that's everything for this video. I suppose everything is correct. Let's check. Number 1 is 243. Number 2 is 64. Number 3 is 4. Number 3 is 4. Number 4 is 135. Number 5 is 3. Number 6 is these two answers. These ones. Hang on. By the way, for number 6, we can actually make an approximation. Place these values in the scientific calculator and we will get an approximate decimal counterpart. So, shift e raised to 3 minus 2. That is, in decimal, approximately 18.08553692. Right, the number is quite long. Right? And for the other answer, negative e raised to 3 minus 2 is approximately negative 22.08553692. So yeah, that's it. For number 7, let's have an answer that's also in decimal form. Place ln in the scientific calculator. Ln 25 over 3, I suppose. I'm sorry. I'm not sure why the scientific calculator only provides... it assumes that 25 over 3 is like this, written like this. I'm not sure how or why, but please correct me if I'm wrong. I'll just place the approximation here. 2.120263536. So yeah, that's it. Please rely on this answer more than the decimal. The decimal may be wrong, but yeah. Please understand or study at your own risk. X is equal to 2 for number 8. Yes, that is correct. Alright, thank you for watching this video. Everything is fine now. I hope you learned something.